All right, Course 2, Lesson 84, Algebraic Terms. Now, this is a lesson I do not want you to freak out about. You can do it. Just stick with me. They're going to be using a lot of weird words, okay? So we have polynomials. Poly just means many. So this is an algebraic expression with 1, 2, 3 or more terms. Now, like terms have identical variable parts. So we're going to have different kinds of polynomials. We have monomial, which is one term, binomial, 2, trinomial, 3, because mono means 1, bi means 2, tri means 3. So what type of polynomial is the term m squared plus 5n squared? Is m squared exactly like n squared? No, m and n are different. It doesn't matter that n has a number with it at this point, all right? So how many different terms we have? 1, 2, so this is a binomial, okay? Binomial, 2 different kinds. When a term is written without a number, it is understood that the number is 1. When a term is written without a sign, it's understood that the sign is positive. All right, here we go. What if a term does not have or contain a variable like -4? We call that a constant term because the value never changes. That doesn't vary. There's no variable, right? It's a constant. -4 is always going to be -4. Constant terms can be combined by algebraic addition. All right, so I have 3x plus 3 minus 1. All right, before you look at this, I have 3x. Is that the same as 3? No. But are 3 and 1? They're just numbers. They're constant terms without any variables, right? So this equation actually should look like this. 3x plus 2, because 3 minus 1 is 2. Added plus 3 and -1. Now, variable terms can be combined if they are like terms, meaning that they have identical variable parts. So -3xy to the second plus xy to the second, those are like terms because they both have an x, they both have a y, they both are to the power of 2. All right? So remember, if it doesn't have a number in front of it, we assume that the number is 1, positive 1. So -3 plus a positive 1 would be -2xy squared, because these are the same. So we just remember that that's like a 1. Are you still with me? Let's do some more. All right. We will use the commutative and associative properties to collect like terms, all right? So 3x plus y plus x minus y. I have x's and y's, right? I have a bunch of x's and y's. So commutative, let's just rearrange our community. Let's put the x's together and the y's together. So now I have 3x plus x plus y minus y, okay? Now associative, I'm just going to put parentheses around them. I'm just going to group them with my associates, right? So 3x plus x in parentheses plus y minus y in parentheses. And then I'm going to simplify it. How many x's do I have? Remember, if it doesn't have a number, it means you can think of the number 1 in front of it right here, right? So 3 plus 1 is 4x. Y minus y is 0, so the answer would just be 4x. I know. You can do it, though. I know you can. Let's try another one. Here I used my little highlighter pen, all right? So we have all these different terms. We're going to look for like terms. Well, I have just a plain old x here and a plain old x over here, so I underline those in green. And then look, I have an x squared here and x squared here, so I underline those in orange. And then I have a plain old constant term without any variable of 4 and a -1. So now let's use our commutative and throw these together. All right, so I have 3x plus or minus x. 3x minus x. Remember, I could think of that as 1x if that helps my brain. plus, now I'm going to do the x squared. 2x squared, do I have any more x squared? Yes, plus, and she'll go ahead, just put 1 there if it helps you, 1x squared, plus 4 minus 1. Now let's go ahead and use our associative and just group them together so our brain doesn't go into a spasm at all. All right, here we go. See, now it's much easier, right? We're just breaking it down. So 3x minus 1x, that would be what? 2x plus, all right, so what's 2x squared plus 1x squared? Well, that would be what? 2 plus 1 is 3. 3x squared. Not too hard. And then what's 4 minus 1? 3, so plus 3. And that's it. That would be my answer. I don't have to do any other figuring because no one is telling me what x is worth, right? So this is the most I can do. I've collected my like terms. That's all I can do. All right, now your practice set. It's going to ask, well, it wants to know, can you name what kind of polynomial this would be? Here I have an x squared and a y squared. I have how many? 1, 2. So this is binomial, right? Because I have 2 different variables. How about this? 3x squared plus 2x plus 1. Well, how many different kinds of numbers and variables do I have going on? I have a x squared. Well, that's different from the x, and this one doesn't even have a variable, so I have 1, 2, 3. This would be trinomial. This, don't get confused. This is just one big number. So guess what it is? Monomial, right? It's just there's no other number over here. This one, x squared y and then xy squared. Those are different. So this again is binomial. Now, it's going to ask you, can you collect like terms? We did it a little bit up there. So I'm going to look for just my x's. All right, I have an x. Well, I only have one x. All right, so I have an x. X. Now, I have a 3 and a 5, so I'm going to say, because this would be plus, right? So I'm going to say plus 3 minus 5, because that's what this one is. And then I have plus x squared plus 2x squared. Okay, now I'm going to put my little parentheses so my brain doesn't explode. I know, sorry, I'm doing this one-handed. It's kind of hard. All right, so rut roll. What's going to happen here? I'm going to have a positive number or a negative number? I'm going to have a negative number. That's right. I'm going to have a negative number. And what they usually want you to do is order them with your variable with exponents first. All right? So let's just rearrange our brain, and we're going to put this down first. So x squared, or 1x squared plus 2x squared is what? 3x squared. That's right. Plus, do I have, what do I have for my x's? I just have the 1x, so I'm just going to put x. Now, since 3 minus 5 would actually be what? Negative 2, so I'm going to write minus 2. Okay, and that's it. Now I'm done. It's just gathering like terms. Don't worry so much about the numbers in front right now. Worry about just collecting the like terms. I know it's kind of weird. Here, let's do one more. This one, they're using, where'd I go? Here we go. They're using pi as a variable, which they can do, right? Because it is a variable. So I have 3 pi. I'm going to gather my like terms. 3 pi minus pi, which is really just 1 pi, plus, and now I don't have any other variables, but I have my constant terms here. So plus 1.4 plus 2.8. Wah! My paper's slipping. Okay, put parentheses around so my mind doesn't explode. All right, so 3 pi minus 1 pi is going to be 2 pi's, right? Plus, and then what's 1.4 plus 2.8? Well, that would be 4.2. Had to do that in my head a minute. Check me, see if I'm right. I think that's right, 4.2. And then that would be it. That's it. That's all I have to do. I don't have to do anything else because they just wanted me to collect like terms. All right, so it seems kind of confusing, but it's not really too bad. Here's your assignment. You're going to do practice F and G, then 2, 5, 6, 7, 8, 9, 11, 12, 13, 16, 17, 18, 19, 22, 26, 28, 29, and 30. And the secret word, donut. All right, that's it. Good luck. Wait a minute. Do at least this first row if you can, and then we'll work on the rest in class. Do the very best you can. I will see you in class. Bye-bye.